Good morning, everyone, or good afternoon, or good evening. Depends on what time you're watching this lecture. My name is Muhammad Zishan Big. I go by my middle name Zishan. That's why in email and in syllabus I made a mention of it. Not that I'm ashamed of my first name, but everybody calls me by Zishan. So if you've taken a previous class with me, you'd know this already. But just thought I'll mention it. And I don't want you to get confused when you see the name in the email. Um, So this is our lecture one, and I apologize. I still have, I was delaying this lecture uh, just because my voice was so bad. I was coughing, sneezing. I still am, but I'll try my best. I delayed it as much as I could, but you guys need to have some material online. This is mostly going to be a recap. Since this is you know you've had exposure to programming languages before, you know chapter one and two, and it's just going to be a quick recap, some of the basic concepts and stuff like that. What you'll also see me is I don't stick to one compiler. I use an online compiler for a smaller program, and it's the same expectation from you guys. Is when there is a programming assignment, you can use any compiler that you want, and then as long as the source code is going to compile and run, I don't mind playing around with it. It's okay. I'm not gonna force you to use a Linux-based compiler or a Windows-based compiler or a Mac-based compiler. Use whatever you are most comfortable with. Is as simple as that. I found that I remember there was not here at a different place. I was teaching a Java class, and then people had all kinds of compiler. Right, I was using an online compiler. Somebody had Eclipse. Somebody had something else. So I just let them use it, and then they were great. I mean, they prefer using a compiler and or an IDE that they're comfortable with. So, like I said, use whatever you want. So, that's something about the development of environment. Windows, Linux, Macs, we all have different boxes that we like to play in. As I was saying, use at your will whatever you want. For simple, like, oh, you know what? There are two compilers, online compilers that I tend to use very often, and I think I should post a link for them as well. Uh, in the example, you'll see me use them. So typically, when you start writing a program, you are in an IDE, integrated development environment, and that could be on your Mac, that could be on your Windows, that could be on Linux. Like Visual Studio is something that I've used quite a bit, right? And it's available. It's people use it a lot. I use it. I've used it up until my very last job. Now I'm using Java. It's just a different IDE. And then for Macs, I'm not that familiar with Macs. I've never had a Mac. I've always been an Android and a Windows person. And prior to that, I was using Linux. But Mac, I'm sure, has its own. Well, there is a IDE for Windows and Mac, right? But anyways, whichever place you're on, maybe Visual Studio you're using or something else, feel free to continue to use it. And that you can, but here's the thing though, if you're comfortable with something, continue to use it. Don't go ahead to a different IDE in the middle of the class and try to learn it. You can if you want to, but I'd recommend sticking to one that you're comfortable with in the beginning of the class and following through up to the very end. Then there's this concept of test driving a C++ application. Some IDEs will let you open up a class and an object and will fill in stubs for you, or will give you recommendation, or you'll have some things that, hey, test program, test driver, or something along those lines. But the concept, the idea is very simple. All you're doing is, as the word recommends, suggest test. So you've got an application. Let's say you've got a bank teller operation, and the bank teller has the following operations. You can deposit money, withdraw money, check the balance. three simple operations. Okay, so you've got a class, bank teller, and then three. Um, you've got your. There's going to be the mutators and accessors, the gets and the sets basically is what you're going to have. But for the three operations, right? So deposit money, withdraw money, and then you've got check balance, and then you also have the ability to update deposit, update balance, etc. What I'm trying to get at is for each one of the operations. So let's say each one of those operations in your class is going to be a method. So you are going to define an instance of that object and call each one of the method. And you're going to check the input and the output. So basically what you're doing is you're ensuring that the method, the operations of the class are working as per desired. Now there is also a similar concept, TDD. I don't know how much the book's going to talk about it. It kind of mentions it. Test driven development. Now, we've done it in the past. We spent 2 years, several years ago. This concept was new and then everyone was on board. So in here, you actually write your test cases before you write the code. Now, you might be thinking, well, hold on, how do you know what the operations are? What are the input and what are the output? Well, you would know what the operations are and the input and output at the high level. So first you would go and write your test cases that these are the operations, these are the input, these are the output, that's what the expectation is using asserts or whatever framework you're using for testing. You would test the input and output and the validity of those of those operations. This way, your test suite is solid. Now you go ahead and start writing the code. And as and when you're writing the code, you're compiling it, you're running it, you have your test cases up ahead, so you're one step ahead of the game. Um, you are actually testing your code uh, quicker. And what's going to happen is, uh, typically you write your code, you have your unit test, you have your integration test, and then you hand it off to QA or the testing team to test it out. Now, the testing team is going to have an easier time testing your code if you, ideally, if you've done this TDD, test driven development. Um, the bugs are going to be very few. I'm not claiming that there's never ever going to be bugs in your code. Let's say you follow the TDD methodology, you've got unit tests, you've got integration tests. Does it guarantee that there's going to be no bugs? I don't think so. I've never seen a piece of code or in all these years that I've been working, it's more than a decade that I've been working, that's perfect. But we try to reduce the number of bugs. It can be reduced. You can have good quality code and it can go out the door faster using TDD, test driven development. So you've written the test up ahead and then you're writing the code. Okay? Now the next thing I'm going to jump into is once again this is going to be a refresher. Um, the book talks about this, a hello world example. Outputting something to the stream, a hello world, right? So what do you need? You need IO. You need to include the library. And by the way, I'm not going to be covering the syntax because I assume you guys are familiar with the syntax by now, since you've had a programming language already. Okay, using namespace std, include IO stream, that is the input and output library. You have to include that, and see out hello world. So all this program is doing is outputting up until now, outputting a hello world, and then the end out, all it does is puts a new line character over there. And then what it's going to do after that, it's got int I and j. Okay, so it's got two integers. And all we're going to do is we're going to initialize those two integers, add those two integers, and output the result. You can see the result, but just let me run again. Hello world and number 3. Right? This should all be making sense. This should all be very easy for you guys. Let's go back to the slides for a second. Now, I did talk about iOS Stream, right? iOS Stream is nothing but a library, um, and there are two types of library. There's a static library and there's a dynamic library. I'm not gonna go into too much details on that you have to worry about it. Uh, but there is also these boost libraries. What is a boost library? I don't think you guys must have heard prior to this class what is a boost library. Boost library is just a set of libraries for C++ that provides support for tasks and structures, such as number generation, multi-threading, image processing, regular expression, and things like that. It's there to make your life easier. Some of the boost libraries are file system, thread, regex. Regex expressions are very useful if you've dealt with them in the past. I still continue to use them up until today. This is not an exhaustive list of boost libraries, but these are just three. Know that they're there. They're there to make your life easier. Um, and at some point, you're going to get a chance to use them. Okay, hopefully, so far, so good, right? And one thing you'll see me mention quite a bit here in the class is always try out examples, play around with examples, compile your code, run your code. That's the only way you're going to get familiar with it. Typically it's going to be a half-hour session, at most 45 minutes, but I like to keep it at half an hour because the attention span for folks is usually half an hour. Um, but uh, but at that half hour, it's easier for me to explain the concept. But for you to get the concept, play around with the example, we're talking more than an hour. So make sure you do your homework. Ideally, what you should do is you should read the textbook also, play around with a few examples, listen to the lecture. That will make and make sure you do all of your homework assignments. So if you've read the chapters, you've done the homework assignment, you've listened to the read the chapter, uh, listened to the lecture, done the homework assignments, um, you play around with a few examples, you should be solid. You should be, honestly, you should be getting an A in the class. I'm not going to try to make this class super hard and not super easy. It's going to be right there in the middle. For some of you, it's going to be really easy, though. You will say, well, this is a piece of cake. I always keep in mind the guy that's at the very end, the slowest guy, the one that's struggling. Him versus the guy who's breezing through it, both of them, uh, I look out for both of them, right? So, and I try to set the pace and the homeworks and the midterm right there in the middle. Uh, so if you're struggling, I'm there to help you. If you're breezing through it, continue to breeze through the class. Okay, so like I said, you should be getting an A if you follow those recommendations. Another refresher, continuing on with this, right? Equality operators, right? These are the operators that you probably looked at and been through and used them in the last class. A is equal to B. A is not equal to B, less than B, greater than B, less than or equal to B, greater than or equal to. And then keep in mind the syntax, right? If you're looking for equality, it's not one equal to, because if you say A equals to B, it's a logical error. What's going to happen is it's an assignment. A is going to get the value of B. It's still going to be true, whereas it could be the case that A is not equal to B. Uh, the other sets of operator is the and or operator, right? The logical operator. And what happens is if you get uh, true and false, okay? Zero is false, one is true, but in binary code, it's the trues are represented as one, and false is represented by two. Uh, so even though in C++ and in Java, you'll notice the use of the word true and false, behind the scenes is actually written as zero and one. So A and B both are false, it's false. If one of them is true, it's still false, right? So it doesn't matter. A is false or B is false. Final result is still false. Both of them's got to be true in order for the output for A and B to be true. That's for the AND operator. How about for the OR operator? For the OR operator, either one, A or B, has to be true. If both of them are false, final output is false. Like I said, in this case, B is true, so it's true. A is true, it's true. Or both of them are true, it's true. Okay, so that's all I wanted to cover for the operators. Okay, so now I'm gonna dive into and talk about classes. You might have had exposure to this already, but this is gonna be it's gonna be a refresher. So some of the things here is this is a simple class square. Okay, now the syntax is the same as you might have seen with other classes. The keyword that you ought to be using is class. Okay, class open curly brace like this, and then you close the curly brace with a semicolon, and everything in between goes into the definition of the class. Um, and the things that you should keep in mind are the keywords private and public. There is also a protected member, but I'll come to that at the end. Um, Private keyword means that everything that's in the class is only viewable to the class itself. Anything outside the class may be a derived class, does not have access to it. Anything and everything after the public keyword is open and viewable and subject to change and can change by anything outside the class. It may be a derived class or anything else outside. And then there is a third keyword which is protected. And the protected keyword is kind of unique in the sense that anything and everything outside the class does not have access to the protected members. However, if a class is derived from that, if you have a derived class, that has access to the protected member. So, the more you use, inheritance, you'll come across protected. I mean, but private and public are mostly used. And they help us honor the encapsulation. All encapsulation is a hiding of data. We always use this example, at least in the past, as you go to a bank teller, the hidden information is your account information, right? Your account number, your account details, etc. It's all probably private. Um, and in this case, Square has a double, which is a side, and that is equal to 1, which is private. And then in the class, there is this concept of getters and setters, mutators and accessors. Um, Getters are accessors, which means that they give you a function, a ability to find out the information of the data member. In this case, we have double get side. And so double get side, what it's going to do is if you have an instance of this object and you call get side, is going to tell you what the side is. And also the set side is going to give you the ability to set side, which is a mutator. Okay, so that was for the getter and setter. Um, Now you know how to access the members and you know how to declare them as public and private and protected um, as well, although the example shows private, but those can be protected as well. The other thing that I'm gonna kind of get into is the constructors of the class. What happens is when you first declare a class, in this case, you don't really explicitly see a constructor. If you do not give a constructor, then the compiler will set one up for you. And look at this. When you call square, when you instantiate an object of that class, the default constructor given by the compiler is invoked. Um, Now, in this example, I have a constructor, a user-defined constructor. Okay, so the class is wall, public, everything is public in here. It's a very simple class. And I have a constructor for this, which is wall. Um, and in wall, there's nothing there, right? And when I instantiate an object of wall, the default construct, well, in this case, the constructor that I've given, is going to get called. This implementation and the compiler's implementation is this case is same. It's a default empty constructor. Now the constructor is kind of like the basic foundation of your class. That's how the class gets built. You can initialize the private data members. Not only that, the you can like for example, this is a second one extending on wall. So I've got a private data member called length, and what I'm doing is I am setting length to 5.5, and then now I'm outputting something. When you run this program, it's going to say creating a wall, and then the length is such. Now this is a constructor when you're actually doing something, and that's the foundation, right? You're actually constructing the class, the object. In this case, you're assigning a number, a double, to length. Now the first was an empty constructor. This one we're doing something. You can also pass in parameters to the constructor. So this is the same class, wall, except it's taking into double. So the wall has a height and it has a length, and and what we're doing is in the constructor takes in the height and the length, and then it assigns it appropriately, and then this is calculate area, which is a method, a public method that you can call. So if you run this class, what's going to happen is it will tell you what the area is after calculating the height and the length. So keep this in mind. Now there's no upper limit for the number of parameters that a constructor can take, 1 to 0 to n. Okay, uh, so you can you can initialize all your variables in there. Okay, hopefully that's clear. So that's what I wanted to get from this first lecture. I will see you or talk to you in the next one.